When printing at high speeds, such as 120 millimeters a second, does the HyperCube CPU keep up with the fast print moves? Let's find out. With my old Replicchio Prusa i3 frame, printing at such high speeds was only a dream, as the frame would rattle and vibrate like crazy. But with a sturdy cube design constructed out of 2020 aluminium sitting on rubber feet, print speed is no longer an issue. However, printing at high speed taxes the processor of the 3D printer, in this case an Arduino Mega 2560. The CPU is an Atmel 8-bit processor running at 16 MHz. It sounds like something from 30 years ago, and you wouldn't be far off it. And we're here asking for this thing to calculate the Core XY kinematics before sending the print commands to the stepper drivers. The issue of print speeds with Core XY and Delta kinematics are nothing new. There's plenty of forums online discussing this. Even the RepRap wiki has a page on this. But we can test this ourselves. For the HyperCube, being a Core XY scenario, here's a couple of test pieces that I'll be printing to see if the speed actually impacts either of these two shapes. So here is just a 30mm cube and a 30mm cylinder. And here are our test subjects, the cube and cylinder, printed in speed ranges between 33 millimeters a second all the way up to 100 millimeters a second. Now the cube printed just fine. There was no issue with the print head stuttering while it was traveling across this, because the G code is saying from this location, go to this location, and the actual processing time to do that is quite minimal. So even at 100 millimeters a second, there's no obvious pauses or stuttering from where the print head was waiting for the Arduino to tell it to move to the next position. The only issue here, of course, is printing at 100 millimeters a second. Each layer was quite short, less than a few seconds, so the corners, especially up toward the top here, are a little bit melted. The cylinder, however, fared poorly. Anything above the 33 millimeters a second print speed started to stutter terribly with the print head. You saw it was pausing and starting as it was rotating around the cylinder. And as I increased from 50 to 66 to then 82 and finally 100 millimeters a second, the actual speed of this part didn't increase at all. The print head was too busy waiting for the Arduino to process the next command and tell it to move to the next particular location. So when printing curvy or organic objects like this, increasing the print speed doesn't always net you a faster print. What happens when printing an object like the Gecko? This Gecko was printed in speeds ranging from 70 to 100 millimeters a second, and this particular object has come out just fine. There's no little stutters or any particular issues that I came across with just printing the cylinder. And part of the reason why an object like this prints okay is because, as you can see, it's not just a pure circle. It's having to accelerate and decelerate throughout all these intricate moves. So therefore, it's never really attaining that full 100 millimeters a second print speed. In fact, the only part of this which ever really gets to that 100 millimeters a second is the actual infill inside this part. Printed at 0.1 millimeter layer height with 5 perimeters and 3 top and bottom layers, this has come out absolutely beautifully, and I'll take a few high-res photos of this, but I'm really happy with the way that this prints even with the 8-bit Arduino processor. And for the next test, here are the Pion 230 quadcopter arms printed at 100% infill. One of them printed at quite a fast speed, 120 millimeters a second, whilst the other was printed quite slowly at 40 millimeters a second. So this one's 3 times slower than this one. And you would think that this one would print 3 times faster, but that's not the case. The printhead still needs to accelerate and decelerate throughout the entire print. But even so, we've only reduced the print time by 9 minutes. This one here took 52 minutes to complete, and this one here 43 minutes to complete. So yes, it's faster, but not a great deal faster. Now, even though this is a geometric shape, there are still some curved details to this particular part. So the rear of the arm here is curved, and also all the mounting holes are also curved. So that started to produce that stuttering that we saw with the cylinder earlier. And I'll show you the difference between them two now. So the one on the right here is printed at 40 and the one on the left at 120. And you'll see all this rough surface is where the printhead started to stutter and pause as it was going around, where this one over here is okay. And that artifact is the same all the way around that curved surface. And then when we get to the straight, you'll see that they're both similar. They're both able to print that particular face without too much of a drama. And then we get back to some more curved areas, and the stuttering has reappeared all the way around the curved areas of this particular part. And for our last test piece is the low poly Pikachu, printed at 120 millimeters a second, scaled up to 150%. Printed hollow with 3 top and bottom layers and 3 perimeters and a 0.2 millimeter layer height. There were no stutters or pauses from the printer. As there are no curved edges on this particular part, it was able to maintain the 120 millimeter per second print speed without all the issues with having a curved surface. So that's something to keep in mind with the particular models that you're printing with an 8-bit processor. All of these tests were performed with Marlin 1.1 release candidate 7 loaded on the Arduino. There was no LCD screen plugged into the RAMPS board, nor was there an SD card. Everything was being fed from the PC via USB. I'd like to try in another video Repetier, as Repetier boasts faster print moves as opposed to Marlin, so we might be able to get faster printing using our existing 8-bit hardware without the stuttering. So that's something that I'm eager to test. But I'd also love to jump across to 32-bit software and hardware as well. As time progresses, there's only going to be more and better features that are going to be available to us, and these fairly archaic 8-bit boards can only take us so far. But in the end, there's nothing wrong with 8-bit software or hardware. It works just fine, as I've showed you and as you've been using up until now. As long as you don't mind slowing down your printer a bit to attain the best quality possible from the parts that you'd like, then you're good to go. And at the price point that the 8-bit hardware is available for, I mean, you've seen the entire Arduino and ramps kit with the 5-stepper drivers and cables and so on Banggood for under $25 US delivered. It's really hard to warrant jumping across to 32-bit unless there is a really good, compelling, or multiple compelling reasons to do so. Hey, thanks for watching. If you're thinking about making a HyperCube 3D printer, please check out the Banggood links provided in the video description and on my Thingiverse page. Every purchase through those links provides a small commission which helps me produce these videos for you. And of course, please subscribe to be notified of my next video.